There are so many particles in the subatomic particle zoo, it's sometimes a little bit hard to keep them all straight. For example, are baryons hadrons? Are all hadrons baryons? Are mesons bosons? Are all bosons mesons? It's so confusing, sometimes even the experts get it wrong. For example, see the next slide. For example, there's a website whose address you can see here that has a graphic that shows that mesons are hadrons, which they are, since hadrons are particles made up of quarks, and mesons are made up of two quarks. And you can see that hadrons are fermions, which have half-integer spins. But wait a minute, mesons have integer spins. Wouldn't that make mesons bosons? And you can see that mesons are indeed bosons, as shown in this statement from this other website. But how can they be hadrons if they're also bosons? What's going on here? Well, fortunately, there's a way to keep all of these things straight. Let me introduce the particle ball. To clarify these relationships, I've put together something I call the particle ball, which is actually a dodecahedron, consisting of 12 pentagons. 5 of the upper pentagons show the various classes of subatomic particles, while the bottom half shows their antiparticles. And there are arrows that clearly show how they're all related, as we'll see in the next slide. Now, by opening up the particle ball and flattening it out, we can see all the particles at once and their relationships to each other. For example, particles that are not fundamental particles, but are made up of quarks, those are the hadrons, as you can see from the purple arrow here. Those include the baryons and the mesons. The baryons consist of 3 quarks, protons, for example, 2 ups and a down, neutrons, 2 downs and an up, whereas the mesons consist of 2 quarks, pions, for example, an up quark and an anti-up quark. And there are other examples, as you can see. The fundamental particles are connected by this blue arrow. They include the leptons and the gauge bosons. Leptons include electrons, muons, and tau particles and their respective neutrinos. Gauge bosons including Z and W particles, proton, gluon, and so forth. The lepton and baryons, they're related by the fact that they have half-integer spins, and they're called the fermions. They make up the everyday matter that we interact with every day. Bosons, on the other hand, have integer spins. They're the force-carrying particles. Pions, for example, are mesons that mediate the force between protons and neutrons in the nucleus. Photons, of course, mediate the electromagnetic force, and so forth. Here's a view of the dodecahedron all folded up, showing the baryons and leptons together as fermions. And here's a view showing the mesons and gauge bosons and how they're related as bosons. One of the advantages of using a dodecahedron is that there's space on the bottom to show the antiparticles, as you can see in the next slide. Here we have the dodecahedron flattened out on the antiparticle side, and you can see the relationships between those particles is pretty much the same as the relationships between the particles. And if you'd like to make your own particle ball, just send me a request by email, and I'll send you a copy of the particle ball JPEG file for free.